All right, in this lesson, we are going to look at real-world applications of 3x3 systems and solve them using the calculator. And so in each case, we're going to end up with 3 variables and 3 equations. And the number 1 says Billy's restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $150 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came out to $589.50. How many of each type of flower was ordered? Okay, and so the first thing you want to do is look at what the question is. And so the question says how many of each type of flower was ordered. And so that's going to tell you how to define your variables. You can use X, Y, Z. You can use meaningful variables. And so in this case, we have 3 types of flowers. We have carnations, we have roses, and we have daisies. And so they want to know how many of each type. And so I'm going to let C be the number of carnations. And then R be the number of roses. And D be the number of daisies. Okay, so first step, define your variables to be what you want to know. And then that's going to make writing the equations easier. And we have one sentence that tells us the total number of flowers. And so it says there's a total of 200 flowers. And so that means if I add C plus R plus D, I'm going to get a total of 200 flowers. Okay, I also have the amount for each flower. Carnations are $150, roses are $5.75 each, and daisies are $2.60 each. The total order was $589.50. So everywhere you see money, those dollars are always going to be in the same equation. And so carnations were $150, so I would have 150, or you can just do 1.5 C, plus roses were $5.75, so 5.75 R, plus, and then daisies are $2.60, so 2.6 D. Add all that up, you get the total of $589.50, or just 589.5. Okay, and so that's our second equation. And then our third equation comes from the sentence that says there are 20 fewer roses than daisies. This part where it says they ordered mostly carnations, that's just extra information. The part we care about is 20 fewer roses than daisies. And so a trick with this, whatever's listed first, you're going to have that variable equals. And so roses is listed first. There are 20 fewer roses than daisies. And so I take the number of daisies and I subtract 20, and that will give me the number of roses. I get the number of roses by subtracting 20 from D. Okay, and so now that we have our system of equations, you could solve this pretty easily using substitution, but the decimals are kind of annoying. And so this is when technology or using the calculator is helpful. And so we need an augmented matrix. And so our C's need to be lined up, our R's need to be lined up, and our D's need to be lined up. Our first 2 equations are good, but this bottom equation needs to be rewritten. And so first I'm going to subtract D from both sides so that my variables are on the same side of the equation. And since I'm missing the C variable, I'm going to put 0C plus R minus D equals the negative 20. That way I can set up an augmented matrix. Okay, and so for my augmented matrix, I'm going to put my C column, the R column, the D column, and then we'll have our constants over here to the right. And so looking at the C's, I have 1, 1.5, and then 0 from the last equation. For the R column, I have 1, 5.75, and then 1 from the last equation. Okay, and then for the D column, I have 1, 2.6, and then -1 from the last equation. And then for the constants, I have 200, 589.5, and then -20. And so this is the blue equation. This is the red equation. This is the purple equation. Okay, and now we can put this in our calculator. Okay, and so your first step, second matrix, go over to edit, choose option 1. This has 3 rows, 4 columns, and then we enter 1 row at a time. Okay, and then second quit, second matrix, go over to math. You're looking for RREF, and then second matrix, option 1. Okay, and so I can see my reduced row echelon form. And remember, this was C, this is R, this is D. So that means C is 80. That means R is 50 and D is 70. Okay, and so I like to go back to where I defined the variables and write my final answer. So that means there's 80 carnations, there are 50 roses, and there are 70 daisies. Okay, for our next example, it says last Tuesday, Regal Cinemas sold a total of 8,500 movie tickets. Proceeds totaled $64,600. Tickets can be bought in one of 3 ways. A matinee admission costs $5, student admission costs $6, and regular admissions are $8.50. How many of each type of ticket is sold if twice as many student tickets were sold as matinee? Okay, and so go to your question. How many of each type of ticket? And so we have 3 types of tickets. We have matinee, we have student, and we have regular. So number of matinee, number of student, number of regular. Okay, and so we know there is a total of 800 movie tickets. So if I add up the M plus S plus R, I should get a total of 8,500. We also know there was a total of $64,600, and then matinee was $5, students were $6, regular $8.50. So 5M plus 6S plus 8.5R equals $64,600. Okay, and then the last equation comes from the comparison. Twice as many student tickets as matinee. So twice as many student. That means there's more students, and student is listed first as matinee. So don't multiply the students by 2, multiply the matinee. So the number of students is twice as many as matinee. Whatever variable comes first, it's going to be that variable equals. That's a trick that will help you write those comparison equations. Okay, and so we have our 3 equations. We just need to rewrite this bottom equation to move the m to the other side, plus the s. There's no r in the equation. And since there's nothing left on the other side, it's going to be equal to 0. Okay, and so for the augmented matrix, we would have 1, 1, 1, 8,500 from the first equation. We would have 5, 6, 8.5, 64, 600 from the second equation. And then -2, 1, 0, 0 from the third equation. Okay, and so you would type that into your calculator to get your final answer. Okay, for this next one, Marina had $24,500 to invest. She divided the money into 3 different accounts. At the end of the year, she had made $1,300 in interest. The annual yield of the annual yield on each of the 3 accounts was 4%, 5.5%, and 6%. If the amount of money in the 4% account was 4 times the amount in the 5.5% account, how much had she placed in each account? So there's your question. How much in each account? Okay, and so I'm going to use X for the amount in the 4% account. I'm going to use Y for the amount in the 5% account. And Z for the amount in the 5.5%. And then Z for the amount in the 6% account. Okay, and so if we add up all of these amounts together, she invested a total of $24,500. Okay, and so she also earned $1,300 total in interest. To get the interest, we would have to multiply by the percent. And so the 4% would be 0.04 times X. The 5.5% would be 0.055. And then the 6% would be 0.06. You move the decimal 2 places to the left. Percent means per 100. So you're basically dividing by 100 when you move the decimal. Okay, and so if we add that up, we'll get 1,300. And then the last equation comes from the fact that there was 4 times the amount of money in the 5.5. So 4% was 4 times the amount in the 5.5. So X, the 4%, is 4 times the amount in the 5.5%. 4% was listed first. The 5.5 was listed second. So it's going to be X equals. Right? And so we need to move this Y to the other side. Put 0Z as a placeholder. And since there's nothing left on the right side, it equals 0. You have to rearrange this equation in order to set up your matrix. Okay, and so my matrix would have a 1, 1, 1, 24, 500 from the first equation. My second equation would be 0.04, 0.055, and then 0.06 equals the 1300. And then my last equation would be 1, negative 4, 0, 0. Type that into your calculator to get your answer. Okay. Number 4 says the state fair sold admission tickets at a price range of 3 different age groups: adults, teens, and children. The adult price was 16, teen price was 6, child's price was 4. A group of 30 people attended the fair together. The total price for all of them to enter was $244. The number of teens in the group was double the adults and children combined. How many adults and teens and children were in the group? Okay, so I'm going to use A for the number of adults, T for the number of teens, and C for the number of children. Okay, define your variable to be what you want to know. And the question was, how many adults, teens, and children? Okay, and so if I add up the adults plus the number of teens plus the number of children, I will get a total of 30 people. Okay, and then now we have an equation for the total money as well. The total was $244. The adult price was 16, teens price was 6, children's price was 4. So adult price 16A plus teens price was 6, and then children's price was 4, and the total came out to $244. And then now we have a comparison. The number of teens was double adults and children combined. Okay, the number of teens is double the adults and children combined. So add up A plus C and then multiply by 2. Okay, so first step we have to do is distribute the 2. And then you can move the 2A and the 2C over, or you can move the T over. And so that would give me, let's write the A first, 2A minus 1T plus 2C, and then there's nothing left on the other side, so equals 0. Okay, and so our matrix from the blue equation, we have 1, 1, 1, 30. From the red equation, 16, 6, 4, 244. And then from the last equation, 2, negative 1, 2, 0. Type that in your calculator and get your final answer. 2 more. Clark High School prevailed in Saturday's track meet with the help of 20 individual event placers, earning a combined 68 points. A first place finish earns 5 points, a second place earns 3 points, and a third place earns 1 point. Clark High had a strong second place showing with as many second place finishes as first and third combined. How many first, second, and third place were there? There's our question. How many first, second, and third place were there? So I'll let X be the number of first, Y be the number of second, and Z be the number of third. Okay, and so if I add the number of first place winners plus the number of second place winners plus the number of third place winners, I have a total of 20 individual placers. So that equals 20. Okay, and then we also know the total points, 68 points. First place earns 5 points, second place earns 3 points, and third place earns 1 point. So that means 5x plus 3y plus 1z equals 68 points. And then there were as many second place finishes as first and third combined. So second place is first and third combined. Okay, and so you can either move the x and y or just move the y, and that would give us x minus y plus z equals 0. And so our matrix would be 1, 1, 1, 20, 5, 3, 1, 68, and then 1, negative 1, 1, 0. Type it in your calculator and get the final answer. And then last one, 3 students were participating in a school fundraiser. The first student sold 2 candy bars, 7 pies, and 3 jars of cookie dough for a total of $87.75. The second student sold 10 candy bars, 2 pies, and 2 jars for a total of $47.50, and the third student sold 1 candy bar, 4 pies, and 5 jars for the problem cuts off. And so I'll set up the first 2 equations, and then I guess that'll be it. So this one's a little bit different because each student creates their own equation. And so 2 candy bars, 7 pies, and 3 jars of cookie dough for a total of $87.75. And so I think this question was asking how much each one was. And so let's just use X, Y, and Z. X will be the price for candy bar. Y will be the price for pie. And Z will be the price for cookie dough. And so my first equation, 2 candy bars plus 7, I was using X. 2 candy bars plus 7 pies plus 3 jars of cookie dough came out to $87.75. This time the variables represent the money. Money plus money plus money equals total money. Okay, and then the second student, 10 candy bars, 2 pies, 2 jars of cookie dough for a total of $47.50. So 10 candy bars plus 2 pies plus 2 jars of cookie dough for a total of $47.50. And then what we have of the last student, 1 candy bar, 4 pies, and 5 jars of cookie dough. So 1 candy bar, 4 pies, and 5 jars of cookie dough for whatever. And so then you would solve that and it would give you the price. So this time decimals would be okay. For the other problems, you don't want a decimal for the number of first place winners. You don't want a decimal for the number of children. You don't want, you could have decimals for money. So just make sure when you're solving these, your answers make sense. So here I got 80 carnations. That makes sense. And so if you get negatives or weird decimals for things that shouldn't, that should be a sign that something is wrong with your system.